Alright, so this first part is not new. The corresponding angles postulate, we've been dealing with this one. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So we've been messing with those for a while. But now let's think about what the converse would say. Remember, the converse just flips the order. So now if two coplanar lines are cut by a transversal and the corresponding angles are congruent, then the two lines are parallel. So we just took the corresponding angles postulate and we turned it around because that's what the converse does. So example, so here's my picture. So if I know that the measure of angle 1 equals the measure of angle 2. So if this is true, so if the measure of angle 1 equals the measure of angle 2, what kind of angles are these? These are corresponding angles. And if they're congruent, then what can I determine about line L and line M? Then line L must be parallel to line M. If corresponding angles are congruent, then the lines are parallel. So that's what the converse tells us. So now we're going to use the converse of the corresponding angles postulate, the converse of the alternate interior angles, alternate exterior angles, and same side interior angles to prove that lines are parallel. Alright, so this is the converse of the alternate interior angles theorem. You've got it there. Remember, it's just the alternate interior angle theorem flipped around. And there's the converse of the alternate exterior and same side interior. So we should have already known what these are. Alternate interior angles theorem, alternate exterior angles theorem, and same side interior angles theorem. All the converse does is it flips it around. All right, we'll do examples in class, but be familiar with what those are and how we'll use them. Okay, so now we're going to prove the converse of the alternate exterior angles theorem. So we're given that angle 4 is congruent to angle 5. And try to get it to show, but you've got this right in front of you, or you should. So there's angle 4 and angle 5. We're given that they're congruent, and we're trying to prove that x is parallel to z. Okay, so there's my given. I'm given that angle 4 is congruent to angle 5, and I'm trying to show that x is parallel to z. Well, angle 5 is congruent to angle 6 because they're vertical angles. So I know 5 and 6 have to be congruent. But if 4 is congruent to 5, and 5 is congruent to 6, then 4 must be congruent to 6 because of the transitive POC. Alright? And now, if 4 is congruent to 6, what kind of angles are angle 4 and angle 6? They are corresponding angles. And if 4 is congruent to 6, then x must be parallel to z because of the converse of the corresponding angles postulate. If corresponding angles are congruent, which we just said that they were, then the lines have to be parallel. Again, more examples in class. Please just be familiar with the process and how we're doing these. Stuff for you to read and remember. We will do this probably together in class, but see if you can get an idea of what lines would have to be parallel. So look at number 1, go all the way through 8, and see if you can determine which lines would have to be parallel. Again, we'll do that in class. We'll talk about it in class. Alright, so remember this symbol at the top. It means perpendicular. Perpendicular lines intersect at 90-degree angles. Perpendicular bisector. What is a perpendicular bisector do? Well, it's in the name. It's perpendicular to the segment and it bisects it. So it is a line perpendicular to a segment at the segment's midpoint. It cuts the segment in 2 equal pieces and it's perpendicular to the segment. Alright? The shortest distance from a point to a line is a line that is perpendicular to said line. Example on the back. If that's a little confusing, we've got an example on the next page. Alright. Some stuff for you to know and memorize. Wait, some stuff we need to know. Alright, here's a proof we're going to go through. Given that R is parallel to S and 1 is congruent to 2, we need to prove that R is perpendicular to T. So I think we see it okay on the screen. So I'll start with my given. I'm given that R is parallel to S and angle 1 is congruent to angle 2. Given. Okay, so here's line R and here's S. There's angle 1 and there's angle 2. Well, I know that angle 2 is also congruent to angle 3 because they're corresponding angles. Corresponding angles postulate. Alright? I also know that angle 1 is congruent to angle 3, because if 1 is congruent to 2 and 2 is congruent to 3, then 1 must be congruent to 3 because of the transitive POC. All right. I also know not only are 1 and 3 congruent, but I also know that they're supplementary because they form a linear pair. Okay? So now this is sort of a new step. Combine these two. If I know that 1 is congruent to 3 and I know that they're supplementary, then what must be true about angles 1 and 3? If they're congruent to each other and they add up to 180, then they both have to be right angles. And the definition we're going to use here is the congruent supplements theorem. We could talk about that more in class. But it should make sense. If 1 is congruent to 3 and 1 and 3 both add up to 180, then they each have to be 90 degrees. And so if angle 1 and angle 3 are 90 degrees, then R must be perpendicular to T, because that's what the definition of perpendicular lines means. Again, examples in class. All I'm asking for when you're going over these notes is be familiar with the steps. Even though we might have questions, that's fine. But I need you to have an idea of how this stuff works. And we'll do examples in class to help solidify stuff. All right, so now, sample problem. All it's asking us to do is solve for x and y. Few different ways that we can do this, but if I cover this side up, I've got a linear pair there. And if I cover this side up, I have a linear pair there. So let's think about what I could write on my paper. Well, if this is 90 degrees and that's a linear pair, then this angle has to be 90 degrees. And if this is a linear pair on this side and this angle is 90 degrees, well then this angle must also be 90 degrees. So I can write this on my paper. So I can say that 22x plus 2y has to be equal to 90, because this must be a right angle. 19x plus 4y, that must also be equal to 90, because this must be 90 degrees. Well, now if I look closely, this should look similar to, you know, those problems that we do with the quadratics, and we try to find the nth term and the an squared plus bn. Remember how one of the steps is we find the two mini equations and then we subtract one from the other to get the letter by itself? That's what we're going to do here. But if I look here, if I subtract them the way they are right now, the x's or the y's, they're not going to go away. So I've got to do one step first. And in this problem, it looks like it'll be easier to make my y's go away. So I'm going to multiply everything on the top equation by -2. And that's what I've got written right here. Times -2. Everything in this top equation, multiply it by -2. And I'm going to slide over here because I've already done it. And I have it written here. So 22x times -2 becomes -44x. 2y times -2 becomes -4y. And 90 times -2 becomes -80. I kept the bottom equation the same. But now notice I can add these up now, and they'll go away. -44x plus 19x is -25x. -4y plus 4y, those go away. They cancel each other out. And -180 plus 90 gives me a -90. So my y's just went away. Divide both sides by x, and by -25, and I get x is equal to 18/5 or 3.6. It actually works out to a nice decimal. Okay, so I got the x. Now to get the y, all I did was come back into this one, because I know that 22x plus 2y has to be equal to 90. But now I know what y is. And I put 18/5 there, but then I just used the 3.6. So 22 times 3.6 will get you 79.2. Still have the 2y, still have the 90. Subtract 79.2 from both sides. 2y has to be equal to 10.8. And so y has to be equal to 5.4. So again, this is algebra. We got to be sure that our algebra skills are where they need to be. So this is going back to the front page, but I told you that I've got an example. So I've got a picture here. I've got point P right here, and then I have this line AC. And so what it's asking us to do is just identify what is the shortest segment from point P to line AC. So, if I'm a little ant and I'm standing on point P and I'm going to walk towards line AC, what is the shortest path that I can take? And what we discussed on the first page is the shortest path that I can take from point P to line AC is a line that is perpendicular to line AC. And so there's my right angle. So PB must be perpendicular to line AC. So then the shortest distance from P to line AC must be PB. So there's my first answer. The shortest segment from point P to line AC must be segment PB because it's perpendicular. Now I'm asked to write and solve an inequality for x. So I'm going to do this first and then I'm going to explain. So if I know that PB is the shortest distance from P to AC, then PA, the distance from P to A, has to be bigger than the distance from P to B. If PB is the shortest distance from P to line AC, then the distance from P to A must be greater. And so the distance from P to A is x plus 3. And the distance from P to B is 5. So PA, the distance from point P to point A, has to be bigger than the distance from point P to point B. Now I just substitute in, because PA is x plus 3 and PB is 5, so x plus 3 must be bigger than 5. Subtract 3 from both sides and you get x has to be greater than 2. Alright, try doing the next one on your own first. Again, you'll benefit from this more instead of just copying what I'm doing if you actually try one on your own. We'll do a bunch of examples in class, but try one on your own. See if you can name the shortest segment and then write an inequality for x. Pause it now and try to do it on your own. Alright, I'm assuming you already paused it and are back now. So, shortest segment from A to line BC has to be a line perpendicular. There's my right angle. So AB must be the shortest segment from A to line BC. Now, segment AC, this one, has to be longer than segment AB because we just said that AB was the shortest. So segment AC must be longer than, it must be greater than segment AB. Substitute in, and so 12 has to be greater than x minus 5. Add 5 to both sides and I get 17 must be greater than x, or x is less than 17. Again, a lot of examples to be done in class.